Good evening, everyone. I am Brendan, KE0FCG. I'm the president of SLSRC, and I want to welcome all of you to our live stream this evening. We are building a kit from KC9ON.com, an offset attenuator for fox hunting. We are doing a fox hunt in the near future. We haven't planned a specific date on that. We're kind of waiting to see how COVID works out, to see when we can start meeting in public, and that'll kind of determine that date. But until then, we're going to build this kit this week. Next month, we're going to be building a Yagi antenna, and we haven't determined what we're going to do the month after. So if you have any ideas, feel free to throw them in the comments. Tonight we have with us Larry WB0SMF, Art K8ALL, Mark A0OME, and we have Kyle AA0Z. Everyone wave.
Hello. Hi, Mom.
Hello.
So Art and Larry are building along with us and watching the chat and just hanging out. Mark and Kyle will be chipping in and showing us a little bit of their soldering, a little bit of how they like to build kits, because everyone has a different style. And then I'll be doing a little bit of stuff in between. So, first up, if you've never built a kit before, it's important to have some of the basic tools. First up, if you're doing soldering iron. The quality of the soldering iron is great when you're great at soldering, but until then, anything you got works. If you don't have a soldering iron, getting one from Harbor Freight or from the hardware store is a good option. I have both a super cheap one that I bought off eBay, just as an example, and a slightly better one that's out of the camera shot that I'm actually using tonight. But you only need one. Other than that, you'll need wire strippers, flush cutters, very helpful. If you're getting old like I am, your choice of magnifying device. And then something to hold your circuit board. A soldering iron cleaner of your choice. I like the brass brush. A lot of people like the wet sponges. And then last but not least, your solder itself. I actually have two different types of solder here. Let me go to my tight shot and I can show you the difference. Get in the nice clear shot there. So the one on our left is a small diameter for electronic soldering, and the one on the right is a large diameter that you'd use for something like soldering up a antenna cable or something bigger. Kyle also has some of the thinner stuff that is electronic solder. It is electronic solder, not plumbing solder. So you're looking for rosin core, and don't try lead-free if it's your first time soldering. Lead-free solder is very difficult to use.
I would have switched your camera there.
Oh, yep. So, if you're watching this, you either have already ordered or you're about to order your kit. It comes with a beautiful set of directions. All of your components are individually labeled and bagged. Double check them off of your components list on the first page. It wouldn't be the first time a kit was packed wrong. So check your parts. Fortunately, all the ones that I've gotten so far have been correctly labeled and pretty easy to understand. So you've got all the little parts, the electronics parts. You've got the power connector, you've got the power switch, some headers, some knobs, and the most important part, the circuit board itself. So you're probably asking, as everyone else has, why are we building this kit? As I said, we're doing a fox hunt in the future, but when you get too close to the fox, it's really hard to narrow down and figure out which direction the signal's coming from. So there's two different types of attenuators that people normally use. One is the resistive attenuator, which a lot of people already have. It's a series of resistors that bleed off the extra signal. The other type of attenuator is the offset attenuator that we're building today. What it actually does is adds in or mixes a 4 megahertz signal with the incoming signal and essentially offsets the incoming signal plus or minus that 4 megahertz, and then only gives your receiver a very, very small amount of that signal, which you can then turn down so your antenna is picking up only a very small amount and it becomes more sensitive that way.
You're actually picking up an intermediate frequency, which is very useful.
Yes. All right. So Kyle is going to show us how to build the first part of the circuit.
Hello.
So let me get him up here on screen. There you go.
All right. Kyle, AA0Z, past president, engineering chair, website chair. So we're going to build, you got some instructions here. We're going to build the first two positions here. So you can see my station here. So the first instruction is to install, solder, and clip the excess leads on the following components. You've got R4, a resistor that's 4.7 kilo ohms, C3, which is a capacitor of 220 picofarads, and C4, another capacitor, 220 picofarads. So, and also on the resistor, it shows you the band. So if you're not familiar with resistors, I've got the resistor right here. You can barely see it because my thing doesn't focus. My camera doesn't focus. But there are different bands that show, if you read the bands, it's color-coded on what the resistor value in ohms is. And yellow, violet, red, and gold is 4.7 kilo ohms. So what I do is I take the resistor. It comes in a straight line, and you want to bend that resistor as close to the resistor as possible, and you want to make it into a U shape. So you can see that U shape here. And then you want to find R4 on the board, and it highlights where R4 is. So R4 is right here, and it actually shows the outline of a resistor, and it says R4. So what you'll do is you'll stick that resistor. Doesn't matter which way. Resistors doesn't matter which way you place it in the board. And what I do to keep the resistor positioned is I bend well, first you have to make sure that you're on top. You're putting the resistor and all the components on the right side of the board. So you want to put everything on the board that has the writing on it. Okay, if it doesn't have any writing or it doesn't have any outlines, you're on the wrong side of the board. So you want to make sure that you're on the right side of the board. Place your components through, and then if you can see that, I don't know if you can see, but I basically push the leads at a 45-degree angle, and they actually stick into the board, and you can turn it over with your helping hands, which is just some alligator clips on a base, and you can get this off of Amazon for $10 or so. And what you want to do, you want to put your soldering or your board on your alligator clip, get it level, and you want to solder each one of those joints that you just stuck the components in. So you can see here also, I went ahead and did C3 and C4. So C3 is right here. It's kind of hard to see, you know. And C4 is right here. Those are the two capacitors. And I pushed those through and pushed those leads to a 45-degree angle. And now I'm going to solder those leads. So again, I'll put it in my helping hands here. And you'll watch me solder, which is like watching paint dry. So, the first incision. I will now incise. So you want to get a little bit of solder on the tip of your iron. I've got my iron at 750 degrees. Oh, I don't have enough light. So you want to put your soldering iron down on the component lead and hold it there for just probably 3 or 4 seconds till it gets hot, and then place the solder and get a nice solder ball. And the solder ball should be shiny. It should look like you covered the joint. If you Google what's a good solder joint look like, there's a very good graphic on what a good solder joint looks like, and it will you'll know if it's good or not based on the picture. But so here we go. And you should have a fan. You shouldn't be inhaling the fumes like I am. How about that? And you'll want to position the board after every solder joint to make sure that you got a good position to get your hands in there and your soldering iron. And on this, you want to use a very small tip soldering iron. You don't want to use a big tip because you're going to be soldering things that are close together. So you want a tip that comes to a point almost, so you can get in there and get your solder close to or get the heat next to the component and get your solder in there also.
Hey, guys, this is Larry. I can see Mark's screen here. It looks like he's got some masking tape holding his components in. Is there any advantage to doing it that way, Mark, or is it just personal preference?
I've found sometimes that even when bending, sometimes depending on the thickness of your board or how strong the leads are, it may not want to hold your board or your part tight to the board. So I do a mix. I bend it a little bit, and I usually use the tape for small parts like this.
And this is Brendan. When I do it, I just tack them really quick with some solder. I think you can see in the inset shot that I have the components soldered, but they're not all the way down. So my trick is just get them in there and then come back, heat them up again, and push them in the rest of the way.
I think I don't have enough heat, so I'm not getting good solder joint.
You don't want to use a lot of solder, right? You want to use a little bit, and you can always add more later.
So I'm going to take my tape back off and take a look at this because I don't think these are good.
All right, so I just got done with C4, C3, and resistor 4. You can see that it's not very, let's see. You can see better there. So what I'm going to do here is now I'm going to take my clippers and I'm going to clip these leads as close to the top of my solder joint as possible. These are going to fly all over the place, so watch out.
Show that without any glare.
So after you get done, you'll want to take a look to make sure that you don't have what's called solder bridges, which means that you bridged 2 holes together. So you'll want to make sure you don't have any of that. And then after you're all done, you'll want to clean all this with some alcohol, not the drinking kind. You could try that, but I don't know if it's going to work. So anyway, that's step 1. Let's continue to step 2. So step 2 has a diode, 1N4148. So let's go find that diode. Here's that diode. So let me get that diode out. So here is the 1N4148 diode, and then a capacitor, which is 15 picofarads. So here's that. It's nice that they labeled everything.
Yeah, they did a really great job with this kit.
Because I don't consider myself good at identifying parts, and this made it something that I feel more comfortable with.
Transistor J113.
Note on the diode, make sure you get that line right, or this is not going to work right.
Yep. So we'll talk about that in a minute here. A 2.2 kilo ohm resistor. Where are my resistors? There's my resistor. So that one is red, gold. Red, gold. Okay. So they come in these kind of like these packs here. And so you can just pull this paper off. And then I'm going to put this other resistor back in the case. And then also a trimmer. From
YouTube, one of the people are asking why you're not wearing goggles when you're doing all this clipping and soldering.
We're not role models.
If you're careful, it's not earth-shattering.
Yeah.
Or eye-shattering.
Yeah, or
I make it a point when I clip, I point them away from me.
Does that person work for OSHA?
I'm not telling the name.
All right.
We don't care about the name, just the employment.
Yeah.
All right. So I've got my components out here. Where'd my diode go? Is this the diode?
It's a tiny little glass guy.
With a black bar at one end.
Yeah, okay. Yep, here's my diode. Man, my eyes are getting bad. All right, so...
You're too young for that, Kyle.
Yeah, the diode, D2. So if you take a look at the diode, it has got a line. So if you're looking at the board, and you're reading D2, the line is on your right-hand side. These diodes have a black line on them, and that's where the line gets lined up with D2. So let me bend this diode so it can fit into the... So I bend it as close to the diode as possible that my hands will be able to do. So I make it into a U. And let me get this a little bit more straight. There we go. And then I place the diode with the black on my right-hand side. And I will put these at a 45-degree angle.
And that circuit board has a line there helping you to make sure you're pointing it the right way when assembling.
Correct. So I am going to go ahead and solder this just to get it out of the way.
While you're setting up, I got a quick thing I want to show. This little variable resistor trimmer, if you look on the very bottom of this board, right here, these barely stick through. This is why I use tape sometimes. And I understand why Kyle hasn't done that one yet. It's easier to get some of these other parts in.
All right, resistor, or I'm sorry, the diode is in. Next is C5, which is a capacitor of 15. So I see, I watch. I try to find C5. Holy moly. Ay. There's C5. So capacitors don't have any, doesn't matter which way they go in either. So,
Well, for this kit, there are electrolytics which do,
true.
but not
For
this
this
kit.
yeah, this kit we're good. All right, solder this guy up. I hope that's C5. Is that C5? Hang on.
It's the one right next to the diode.
Yep. All right. Always make sure you're soldering in the right place, kids.
Especially before you trim the leads. Trying to get them back in if you trim the leads is nearly impossible.
And a side note, because these are so close, when you are heating these, make sure you're not putting your iron against more than one component at a time, because some of these can be damaged by heat.
All right. C5 is in. Now, transistor J113. So that is... Let's see. Hang on. Okay, transistor. So this transistor's got 3 leads. And the outline of the board has got a flat spot, and the transistor's got a flat spot. So what you want to do is the middle lead, it goes in the back, and the 2 leads on the right and the left side go on the left and right side, obviously. And you want to align the flat spot up with the flat spot. Oh, this one's going to be a doozy to solder. So I'm pushing these out at 45 degrees. And so your components don't have to set flush with the board. They can stick out a bit. When I say a bit, I mean a couple millimeters. You just don't want them like, a half an inch. So let me solder this. And I need some more light.
And another thing you may see me doing, but maybe not. I haven't noticed Kyle because I've been doing my own, not watching him. There's a thing that you might get with your soldering iron, and what this does is it lets you rub extra solder off, so that way you don't get a bridge.
Mark, you show this
All right.
again. I didn't have you up on
Oh,
up on
absolutely. So I've got a little bunch of brass, like, I don't know what you'd call it, but essentially you just basically just jam that in there, and what it does is if you have extra solder on your tip, it will take most of that off, so that way you don't have a whole ball that's ready to fall where you're trying to solder. So that's how you avoid bridges. Well, one way.
All right. Next to C is resistor 5. So we're gonna make that into a U shape, and we're gonna place that on R5 here. Push that all the way down. Push the leads at a 45-degree angle. soldered up.
This is going to be a tricky one.
Let me hit that again.
Come on, melt.
So is anyone on YouTube
There we
actually
go.
doing this at home along with us, or are you just hanging out and watching?
All right, and the next one is the trimmer, and that goes in VR2, which is this. All right, so set trimmer to the center position. So the trimmer only goes in one way because it's got 3 leads on it. And it
Hey,
kinda
Brendan, do you want to cut back to Kyle's screen?
Oh, yep. Thank you.
So I'm going to trim my leads before I put the trimmer in. Ooh, that one shot out. Maybe I do need safety goggles.
That's not a bad idea. Your safety goggles, our hard hats, our high vis vests. Be ready for any emergency.
All right. So next is the trimmer. And that guide, you don't push the leads in at 45. You kind of just pop it in, and it kind of seats itself. So, gonna solder this guy up.
Now, if you're not certain if you've gotten a good connection, what you might try doing is to use a continuity tester and touch one of your posts and make sure you've got a connection electrically with the next post over on that circuit trace.
Yep.
And it's a good idea to do that before you cut your leads if you're not sure.
So let's just do that real quick. So I'm going to set my multimeter so whenever I don't know if you can hear that. But
Yep.
whenever you test the leads together, it sounds. So let me. Okay, sounds good. Sounds good. I was more worried about these right there. What is that? That is. Oh, those are supposed to. All right. All right. I think I'm good.
And I have a minor issue I want to show. This is good. On my circuit board here.
Hang on, you're not.
Hang on.
Yep, you're
There you
up.
go.
On my circuit board right here where the transistor is, that's these 3 pins here that are close together. If you can see this, when I cut this, these 2 wire leads here are almost touching. So you want to make sure that those are not touching and or cut it farther down, because that can prevent your transistor from working right.
All right. That is it for step 1 and step 2. Who is doing step 3?
I guess I can go ahead and take it. All right. So, step 3. We have installing the capacitor, 220 picofarad capacitor. So, same as Kyle had been doing, we're just going to open up our package, find the 220 capacitor. You did have 2 in there, so that pouch is already open. And if you're like me, you misplaced it on your desk. There it is. Hanging out there in the back.
Okay, we have a question. The question is the trimmer in position labeled RV2? I don't see a VR2.
It's labeled
Yeah.
VR2. My board says RV2. So
Yeah, they reversed it.
Yeah.
Okay.
Yep. Good catch there.
Yep.
Certainly
and it's
on
the
the
only
red
place
board
it
anyway.
fits, so you can't do that one wrong. So our capacitor we're doing right now is C2. If I can do this on camera.
Yeah, I'm trying to do it where I've got better light.
My technique's pretty much the same as everyone else. Shove in the hole, split the legs. But I do my pieces one piece at a time because I'm fat-fingered and lose things pretty easily. So next up is my 1 meg resistor. Brown, black, green, gold. Oh, and I did exactly what I told other people not to do. I wasn't paying attention and put the brown, black, green, gold right there. That's why you check your pieces before you cut them off. That fortunately brings us to the next important tool, a solder sucker. You can use solder sucker or solder braid to undo any mistakes.
Did you do that intentionally, Brandon?
I'm going to say I did. Or
This is a useful technique.
At hand. So if you've never used a solder sucker before, the easiest method is to add more solder. So this is one of my legs. If you have a spring type solder sucker, you cock and then suck the solder out. 1 or 2 shots with it nice and close, or usually pull it out. And then your part is nice and hot, and you'll burn your fingertips, as I am doing. But over time, you'll find more and more pieces of equipment to make life easy. Like if you make mistakes often, like I do, instead of the small forceps, we'll let you grab onto these tiny parts and hold them without burning yourself.
You have another angle, Brandon? Or Brendan? Sorry.
Yeah. That's probably more useful, isn't it?
Yes.
So that is this joint right here. Then I'm out of my camera shot again. Did I get it? Not quite. I'm going to add a little bit more solder to make this easier. Here we go. And there's my resistor. Now I can put it in the right place, which is R3.
And a quick note about that, you've got two different resistors side by side with two different, wildly different values. And if you get those backwards, it can change the behavior of the circuit.
Significantly. And most likely in something this simple, it just won't work. And you won't know why, and you'll just be upset with yourself.
The other tiny suggestion I would make is put those two resistors in the same direction. So that way the tolerance, the gold band, is facing the same way. That helps make it obvious that you've got the right one in the right spot.
Okay, so there it is in the correct spot now. So now it's time for the 1K ohm. There we go. Both my tolerance bands to the right. It's entirely personal preference, but whatever makes it easier for you. I normally go with the left, but it's only for your ease of use. All right. So, next piece is very small part, our actual crystal. So the crystal is a tiny piece of, I think, crystalline quartz that vibrates at 4 megahertz. It's tuned to size of the factory, then put in this fancy metal can so we can actually handle it. And it's the only one in the kit that looks like this. And that's what it looks like right there. 4 megahertz. But you handle them like everything else. Drop them in his hole, bend the legs. So the crystal is not polarized, and so far the only parts we've had that do care are the transistor and the one diode. But we'll have a couple more coming out. So here's where my soldering gets a little bit more tricky, trying to get that one I cut the legs off already. You can see that's the one I need to solder. There's no tail hanging out, so I have to hold it in by hand and hope I can get it to stick back in there. So it's a little bit tiny, so I'm going to have to do that off camera probably. I'm going to have no chance of getting it to stick. Looks like we're there. So just like Mark's trick with doing the tape, if I have a tiny piece that I'm having a hard time keeping in place, I just put a finger on it. Let's see if I can do this on the camera. Put a finger on it, and then get some solder on my tip, off my tip on there. It's not 100% right because you need to use the solder straight from the wire, because normal electronic solder has flux in the middle of the metal, and if you heat it up first and then come back, the flux is already burnt off. So you can only do that to tack your pieces in.
It helps it flow.
Helps it flow. But then after you have it tacked in, you can come back, heat up your joint, and flow in the right amount of solder. As Al said, you can always add more solder, but it's a lot easier. It's a lot easier to add solder than it is to take it off. There's the first leg of my crystal. parts up against the board a little more as a tool to keep your joint from slipping. Josh Kroll says he's been able to use tack putty, which is a great idea.
I'm sorry, can you say that again?
Josh Kroll in the comments said he uses tack putty.
I haven't heard of
glue
that one
tack,
before.
you stick posters to the wall.
Okay.
I assume that's the type of putty he's talking about. Okay. So we got the other leg of that resistor I trimmed off. I'm gonna have to do off camera. There it goes, flowing in there beautifully. And this is a fairly small circuit board. It's not a difficult one, but if you don't do it cleanly, you'll have some issues.
John mentioned that the flux removes oxides from the wires, so you do not get a cold solder joint.
Yes. It's a better description than what I gave. Thank you.
Yeah. And if it comes down to it, if you just have a soldering joint that you just have a cold solder, that's not bad and it has enough solder and everything else is good, you can get flux separately. So you can have that within reach. So I have the type that's in a syringe. You can also get it in liquid, but it just adds a little bit more. Or if you're dealing with older corroded wires, you still need to do a little bit of polishing with sandpaper on, like if you're doing an older antenna wire or a copper bar that you're soldering to. Still polish it up with a little bit of emery paper or steel wool, hit it with flux, and then you can solder it. And that part's just like plumbing soldering. Clean is important, flux is important, and then the last part is heat. So, okay. Now I can.
Well, I will say that angle cutter really makes a world of difference.
Oh yeah.
I have never actually done that before. That's a good idea.
Yeah, you can get super close to the board. Let me see if I can get that in the shot. You actually get way closer than you probably should. You want to leave a little bit there, but I think that one you can kind of see it. You can see the solder joint has that nice little fillet or that curved part to it, and then above that, the wire just barely sticks out. So you're not shorting yourself, you're not taking off too much wire. And cutting into the solder joint, you still have a good connection.
And I just found a bad joint.
Can you get a close enough shot of it to show us, or are we stuck where you are with the zoom?
Yeah, I think so. Right here, these two, there is just not enough solder there. I can actually see through the plated hole. And so what that tells me is I did not put enough in. So I want there to be a little bit more so it'll flow down into the hole. So just touch it and tack a little bit extra solder in there, and that'll help fill it.
Yeah, so all these boards these days that you have pre-made do have plated through holes. So when you do a solder joint, the solder should pull all the way through the board to the other side and fill the entire center. That's what gives you a really good connection.
All right, so now to show the other side of that again. It's a little bit, wow, focus is horrible here. It's a little bit better, and I'm making sure that I don't have a solder bridge between the two. And in fact, a good way to test that is to do my continuity meter. That's good. Uh-oh. Or is that supposed to be? That is supposed to be. Never mind then. That's where this resistor and this capacitor connect together on the board. So I should actually be getting continuity there. And you can barely see a trace in between them. You probably can't on the phone, but there's a ground plane around it too. So sometimes you need to be careful, sometimes you don't. This one you don't.
You also just fall back on the classic, be good or be lucky.
I'd rather be good than lucky. Unfortunately, it's usually the other. Okay, you guys moved past the crystal, right? Onto the last RC?
Yeah. Crystal's in. That is all the way through section 3. I'll give Mark a moment to get caught right back up with us.
And let's see, where's that other? Oh, that's that capacitor. All right. So those will be pretty quick.
And I'm doing the final checks on that part of my board as well.
John had indicated that the wires probably weren't heated enough before touching with a solder, Mark.
Probably.
Ooh, this might be one of my ugliest boards in a long time, but it's hard working around the cameras. Oh, there's another lead. I need to shorten the hair.
I think I just need a little bit hotter iron. I think I'm not getting enough heat onto the part. It doesn't help. This is really the first time I've used this particular iron. That's better.
Yeah, that iron I'm using I've had for probably 6 or 8 years now. It's a knockoff of one of the Heikos. The Heikos are really great, in my opinion. A lot of people prefer Weller, but honestly, a little bit of practice is more important than the iron itself. So however bad your iron is, you'll get used to it, or you'll make adequate solder joints.
It's more about the technique than the actual iron.
Yep. All right, so I'm going to jump on to step 4. Install, solder, and clip the excess leads on the following components. And those components are our 220 ohm resistor, our 0.1 microfarad capacitor,
That's what I did. Apparently I got a step ahead of you thinking that that's where you guys had gone.
So our capacitor is C1, which is up here at the top of the board. And again, since these are ceramic capacitors, you don't care about polarity. Then our resistor is the 2.2 kilo ohm.
Since you're doing that, I'm going to test out my board a little bit and make sure I've got good gaps.
Yeah, this is R2 right up here.
I-E. R. E. S.
Huh?
Somebody said a Morse code.
Oh, It would be good if I actually knew how to do it.
I mean, all I heard was an E. There was an R in there. There's an S. E. A. E.
Uh-oh.
No, I don't know. I didn't hear that.
I got
Kind of like a C.
I've got two of my oh no, the probes were touching. Good. I thought I shorted my transistor.
Yeah, I mean to learn code. I'm gonna do it at some point in the future. Figure at least knowing my call sign and having that memorized would be neat.
I will give you as much Morse code as I really know. Did, 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 did. Unfortunately, that won't help people find me back. Ah.
Okay.
Okay. If you get the helping hands, don't buy the cheap one. It falls apart.
Yeah, I'm a big fan of the vise. This is the Harbor Freight vise. It's got rubber jaws, and you can clamp down on things. It's inexpensive. My cheap helping hands, you can see in the other camera shot, are being used as a camera stand.
So I'm missing a part here.
Which part are you missing?
All right, so D1
Is the only diode in the kit.
Then why is
I'm
it
sorry,
labeled D2 on the board?
I'm sorry, is it D1?
The D1 is the diode, the LED.
Oh.
Oh, it's the LED.
It's a diode. Go figure.
All right, so that's what I was like. I'm looking for a regular, a diode. Nope, it's an LED. All right, so somebody has to. So the longer lead is the positive, but then it goes in the square.
So there's two options with the diode. There's two options with the diode. If you're going to build it into a case, they send along this adorable 3D printed, let me see if it's in there, 3D printed standoff and right angle adapter.
Okay.
That will make it match flush with the knob and the surround of the knob. If you're not going to do that, there is a second bezel that you can see in camera shot right there.
Right.
That just supports it up off the board to get it out of the way and make it look fancier. My test one, you can see how that looks. It has the right angle, so it actually makes it align quite nicely.
Oh, okay.
With the knob.
I see.
But if you're going for more compact, the other one sits in the same spot, doesn't stick up as high.
So, can you buy a 3D printed part for that, or can you print a 3D printed case for this?
Yeah.
There
In
is
fact,
actually
if
one
you go to the
linked.
guy's website, he's got it linked on the project itself.
Oh, well, okay. So I'm not going to do that because I will probably 3D print a case. All right, I'm done.
So I just want to point out while we're doing this, they do make a fun little part identification tool here. And you can put, if you don't know which way it goes, you can put the pin in and turn it on, and it's actually going to light up the LED. And here it shows me the diode. That bar is what should be that flat side of your LED. If you don't have a flat side, this will help you find it. So if somebody's already cut it and you don't know, this is a good way to do it. You can get this tester for, I don't know, what, 10, 20 bucks?
Yeah, and I actually bought the kit version of it off eBay and built it myself. It's not going to save you any money, but it is a little bit of a fun experience. I don't know how you test the pieces you put in it to actually build it. Actually built it and found out I have a bad transistor in here, so it only stays on all the time. So if I plug it in, it's on. So can't test the transistor that's in it.
Now, if you're going to do what I'm doing here and you got this little standoff piece, this is where tape is your friend.
Yeah, any of those bulky pieces, it's much easier.
I just need it to support the weight so I can touch those 2 pins. And these leads are very hard to bend.
All right, guys, I have a hard out at 8 p.m. I got 5 minutes to get ready for my other meeting. So
Thanks a lot for
this
joining
was
us,
fun.
Kyle.
Yeah, this was very fun. I'm going to have to go and take a look at the 3D printed case before I mount the LED or some of these other parts. But yeah, I'm excited to get this out and see how well it works. Now, is the goal here so is it the where do you plug in, for those who are wondering, how do you plug in your antenna?
So we'll actually cover that mostly next month when we build the antenna itself. But I just tacked that piece on. There is a little 4-hole header block that you put on.
Right.
That you attach tails. So you can either hardwire an antenna to this or do a BNC cable, cut off the ends, and put this in the middle of it.
Gotcha.
So if you see this little part that I'm holding up here, it has one side that you insert your wire, and then on the top, there's screws. Make sure that you put this on the edge of the circuit board with these holes out. Otherwise, if you put it in backwards, those are right over your components, and that is not good.
Gotcha. Okay.
So
good deal.
Thanks, Kyle. So I think I should skip over the description here, but next up is a 2-pin header block and the wafer header, which is the power connector. So,
yep, I'm going to go slightly out of order. I'll do that 4-pin since I got it in hand.
Yeah.
But they're basically back to, and it just fell out. And this is why I use tape. But this is on the edge of the board, and it doesn't want to tape to it well.
So I did my trick of just tacking it up with a little bit of solder and not doing a good job with it, but enough to hold it in place. So there's only one little dab on the leg, and it's going to stick there until I'm ready to do the rest of the soldering. Same thing with the header for the power connector. You have to put it in there like this so the polarity is right. But there's no way to hold it in there unless you've got giant gorilla hands, which I happen to, which makes life easier. Or you do the solder on the tip of the iron and just dab it right in there.
Now, when you're doing this 4-pin terminal block, that has so much more metal mass, it's going to really just want to suck that solder right in, as well as the heat.
Yeah, one of the good cheats for that is turn your thermostat up a little bit. So if you have a smaller, lighter duty soldering iron, you can get some heat, dump it in there really quick, and do your solder joint. And then by the time it warms up again, you can do the next one.
Now, I'm actually pretty pleased with those solder joints. I don't know if you can see those really well. Let me turn this just a little bit. Those got a really nice, good well around those.
Yeah, so that's one of those good things you're looking for is the good fillet, which is that curved bead that Mark's showing us, and nice and shiny. Shiny with leaded solder is good. If you're doing the unleaded stuff or the lead-free stuff, you'll pretty much never get a shiny joint.
And I'm using lead-free, so that's actually kind of funny.
Nice.
All right. Now let's do the one he was talking about just a second ago. And this is where the diagram on the board shows that little double gap. And I believe you said that's where the part that the plastic part for polarity has to go.
Yeah, exactly. So if you want to double check that, they send you in the kit the lead with the plug already attached,
which is right here.
Yep.
And this little notch right here is where that goes. And we can see that the red or positive is on this side that I'm pointing to.
Here's
So let me hold that
there
up
you go.
again. So now if I hold that up, I should be able to say this is positive, and sure enough, if I line that up, the positive marking on the back of the board here shows me that's the correct side. So this is the correct orientation. And this is where I'm going to tape it again. Don't need it to stay long, just long enough.
While we're getting to the end, just so I don't forget these, Cliff Razor, our chairman of the Education Committee, wanted to remind everyone that study guides are always available for all the tests, the technician, general, and extra licenses. Email him at education@slsrc.org to get a study guide. And that Cliff Cave this Saturday has another round of in-person testing. So you can go to the website and sign up for testing. And we have a class of trainees going through technician classes that are going to be testing this Saturday. And immediately after testing, they're going to set up a portable station out there and get on the air. So watch for an email, and you can hopefully be one of those new ham's first contacts. And that's real exciting for the new ham. And it's something fun to share in with them.
It could be exciting for you too.
Yeah. I mean, everyone remembers their first contact, so you might be someone else's first.
All right, there. One of them's tacked.
All right. I'll leave it up to the stream. Did people want to see a closer view of how that LED actually gets mounted in that little standoff? It was kind of hard to see on Kyle's camera when he did it. I guess it doesn't hurt. I haven't done it yet. I'll just do it right here on camera. So using the spacer, which is what I'm going to do, insert the two leads into the two holes, aligning the flat side, the short lead, with the flat side of the spacer. So if you look at the spacer up close, you can see this side has a curve, and the other side is flat. So short lead goes to the flat side. So there's my short lead. There's my flat side. And it just sticks right in. The practice kit I did before this, I had to get a little angry with it and push it through. There's a little bit of debris in the hole. But it actually worked out in the end. You might need to get a little drill bit, a little bit, or stab it with another wire. So put them through and then bend them down into these two channels.
And that's what I did here, and you can see how it lines up on the board. Let me tilt that the right way here. So this part actually slides back a bit, but it's doing its job spacing it away from the board.
Yeah.
So even though it wiggles, it doesn't matter.
And I think you can probably tighten that bend into the legs a little bit.
I've tried. It still is kind of... there's just no support locking it in the back is all.
Oh, yeah. There's a little bit of slop in those 3D printed parts, too.
Yep. Now, another good check to make sure you've done it all is pull the board out and see if you've got any open trace holes. Unfortunately, I don't. And I've got no other spare parts, so this is good.
Did you already get the big trimmer pop mounted?
Yes.
Okay.
I did that before the battery port.
Oh, we're going off script. All over the place.
Well, that's what I had in my hand.
Right. So let's see if we can get that in a close shot as well. So the two resistors, we've got the small trim pot on the board, then this big one. So the little one and the big one work together to give you a lot better control, depending on your radio sensitivity. So the little one is a 20K pot, and the big one is a 10K pot. So you actually can turn it down a full 30K of resistance. All right, here's one of those other big awkward parts where I wish I had the tape that Mark has. And here's another trick.
Oh, for the big one?
Yeah.
You know what I did? I set the part down through the hole and then set it on my table at an angle. So that way the board itself does just enough weight to hold, because this part was also on the edge.
I don't know, am I in focus there? I don't think so. There we go.
Yeah, that looks good.
With such a small camera, it's super hard to work around and get in focus. It's small, cheap, low quality. But does the job. So the other thing you do is if it's not on the center, or if it's not on the edge of the board and you have to kind of wing it, you can just hold the piece in place with your soldering iron tip for a moment. Don't leave it there for too long or you can melt it. But... All right, I think I only have my one piece left that I messed up earlier. Which was back here at R4. And then, Mark, do you want to talk about cutting the power lead and soldering in the switch?
Actually, you don't have to cut it. I was looking at this, and from this little adapter thingy here, if you follow the two wires, it's already cut. And when you look at the battery adapter side, it's also cut. So I was looking at the switch they give us, and this is actually a single pole double throw, which means either way you turn it, it's on. What that means is you've got three terminals here. The center one is your feed. So I would put your battery on that center pole and then decide whichever way you want it to be on. And if you see the way this is going, internally, that means the back end of that is connecting these two over here. If I flip this the other way, it's now connecting these two. So it doesn't matter which pair you choose, just pick a center one and either end. And so this is where your helping hands are really helpful again. And I'm going to use the one from the battery, so that would be this one, as my center pin. And what I would suggest is running the wire through the hole like that, and then using the helping hands to hold the wire to support the weight of the adapter, so that way that wire does not move. And now I've got both hands free to tack it in. Now, when you're doing the switch, it really doesn't matter which side goes where. The main reason I'm putting the battery on that center pole is it provides some physical isolation from the battery. So that way you don't accidentally short it with something.
It's a good forethought there.
All right. Now, because this is going to be one of my higher current relative to everything else places, I want to touch the connection and make sure that it's solid, and that is good. Now, because this points this way, that also gives me a through connection. But if I turn the switch, it's no longer connected. So that just confirms. And the next thing, make sure these aren't wrapped and messed up in a way that you don't want to deal with it. And I will take this other wire and stick it out. Now you notice I'm running them both the same direction, so that way I've got insulation to bare wire. And this way I don't risk a short inside the switch. Because remember, this is your battery. Well, I guess it doesn't matter. It just means I would never be able to turn it off.
Yeah, you don't want to run that battery down because who keeps go high one out of our smoke detector to test this. So if you do that, please put them back.
Yeah. Remember, if you let the smoke out, it doesn't work. All right. Uh-oh. I melted the insulation a little bit.
So I did the same thing Mark did, but I didn't do quite as nice of a job pulling through the terminal. I just tinned the terminal and went parallel to it.
Yep, and I'll show you what just happened in a second after I cut the end of the wire off here. So what happened is that warmed the metal of the wire so much it touched the other one, and now this is bare. I can't focus that. It's bare. See it right there?
Yep.
So what I'm going to do to this as a little bit of a safety thing, it's masking tape. It's nothing, great, but I'm going to just take a little strip and I'm going to just hold that through. And this is the tricky part, is I want to slide that under just a little bit so that it is in between the terminals. That way, if the wire shifts, I don't accidentally have a short. And I'm doing this off camera. Sorry, I couldn't get it fit in. All right, now that I've got that down against the base, I'm just going to wrap this around it a little bit. And I'll pull it around a couple of times. Again, not pretty, but this is inside my case. I don't care. Or at least it will be. Now, I forget what the LED is for on here. Is that power?
Just power indicator.
Cool. So what I should do is I have my HF rig sitting right here next to me. I should turn that on to 4 megahertz.
And that is exactly where I'm getting a camera set up right now.
Oh, dude, you are so much ahead of me.
Unfortunately, there's actually too much activity at 4 megahertz right now. I haven't disconnected my antenna yet.
Unfortunately, I can't get my rig to turn on.
Did you unplug it to plug in your soldering iron?
No.
Okay.
But I might have unplugged it for storm protection.
Ah.
And this is a good time to unplug my soldering iron. So the power to that, because I'm leaning over it, and pull it physically out of my way so I don't burn myself. Safety is job 4.875.
Yeah. Safety is somewhere on the list. So in testing, I was having a problem actually getting a place where the 4 megahertz signal is coming out. But you should
yeah,
put it
if
somewhere
you're
close to your transmitter and you'll see it.
Pretty much you want that terminal block to be sitting right there. I'm wondering why my rig won't turn on though.
So mine is working. So here's actually the test one I built before. So maybe slightly different from what you just saw me build. But all the same components, everything else. So all you do to test it after going through and visually checking all of your parts is you look at your terminal strip there, and it literally says on it, Ground, is it ground that it's labeled as, or shield? It's labeled as ground on the radio, ground on the antenna, and then plus on the shield, plus on the antenna, and plus on the radio. And if you can see the screen of the radio, when I start holding it near, no, that's too much glare. I should have just done a screen capture. Still haven't learned how to do that on this 7300. But when I get it close, you can see that there's interference, and when I pull it away, the 4 megahertz goes away. So mine is working just like it's supposed to. That crystal is oscillating and outputting that signal. I do not know of any other easy way of testing that unless you have a...
If you have an oscilloscope or something that can, like a frequency counter, something of those natures, you could actually put that up against the output.
Yeah, frequency counter would be a great option. I know my oscilloscope I have doesn't go high enough because my oscilloscope is also a, we'll just call it budget model out of China.
It doesn't go up to 4 megahertz?
I could not get a good 4 megahertz signal out of it. I could only get noise.
Huh.
So, it was a, if I can find it here, I think I threw it when I threw it, I didn't work. It's a $25 oscilloscope.
Oh, okay.
Yeah.
Gotcha.
So, budget model is being very generous with it. Probably behind everything. But
So,
it works well for
I don't
audio
have the
frequencies,
stuff I
which is
need
what
to
I got it
test it.
for. Sorry, go ahead.
I said I apparently don't have the things I need in order to be able to test it successfully. So that's the other thing I need to do. The other little tip I'll show is, you see I've got all these little tails. The other benefit of having tape, I can go through and use that to pick up all the crap.
Oh, you actually clean up after yourself?
Well, I should. This is my main desk. Otherwise, I'm going to have all kinds of little stuff. And so, as you can see, it's picking up all the little tiny bits.
Oh, that's really helpful. I went to the YouTuber Classic mat that every single YouTuber has, so I can just pick it up and dump it when I'm done. I don't know why every YouTuber has the green cutting mat, but it's nice.
I should have put that down because I've got one, but I didn't. So, you had foresight that I didn't.
All right, do we have any other questions from the chat about testing it or building it or where to buy one of the kits?
No other questions on YouTube. So
Okay.
So apologies for building some of this off camera. First time I've tried doing this, and this was just kind of thrown together as far as my location. I need to do a better job of that.
Well, really, that's how most of these projects go for all of us, is you build it when you get a chance, where you can. Unless you're working from home and have a full-time electronics bench just sitting there ready to go. Most of us are doing this on our kitchen table, so I get it completely. Art or Larry, do you guys have any questions? Anything you saw? I know, Larry, you're kind of playing along at home.
no questions here from Art.
Okay.
Yeah, this is Larry. I don't have any questions. I just appreciate everybody taking the time to do this. Josh Kroll on the chat does have a question, though. He's like, could you explain a little more about the potentiometer? What is the best way to calibrate the small one?
Oh, so it gives the walkthrough and the directions, but you start out with it at center. And when you have it connected to your radio, it gives you broad adjustments. So if you are still too strong when you're near the transmitter, you can turn down that 20K pot, the small one, and see if you have enough control with the big pot.
And you just use a screwdriver like this.
Yep.
Now, a little tip I'll show you as far as putting your knob on. You want to make sure that your arrow is pointing up, or the line is pointing up. You don't necessarily know how far to either side it's going to go. So what I would do, turn it all the way to one side. And so I'll pick a direction. I'll say it's pointing this way. And I will hold this edge, and this is the end that was still pointing, and that goes all the way around to here. So if I turn it so that this is flat, this is the side that is up, because if I now turn it, this tip of my finger is all the way to the one side, and this one is all the way to the other. So this half is up. And by making this straight, I can now line this up so that this points straight up. And then I just simply push it on. And then you can pull it off if you're going to put it in your case. I would put this on after you put your case on. But that's how you can line it up and make sure you're pointing center.
Very nice.
Brendan, we also got a question about where do we get the parts for next month's project?
So next month's projects, we will just send out a parts list of the generic stuff you pick up at the hardware store. You can buy the kit where you're paying for someone else to cut the parts down, but the short version of the parts is a 6-foot piece of 3/4 inch PVC that we're going to cut down into different lengths, a T, a cross fitting, a 25-foot tape measure,
and go to Harbor Freight and buy it for next to nothing.
Yeah, exactly. The tape measure, a 12-inch piece of 12-gauge solid copper wire, and 4 hose clamps or zip ties. It's extremely easy to get stuff. You can buy the kit pre-cut from places. I think with shipping, the one I was finding was $35 to $40. Mark, did you say you'd bought one of the kits?
I bought a kit from an emergency communications group that had them already pre-cut. So that was the nice thing. And it's literally just got a couple of the PVC joints, and I don't even have them glued together. I just have them physically pressed together. So that way I can actually disassemble it if I need to.
Yeah, actually, since we're here, I'll pull mine out really quick.
We just got some more information. Cliff says, good presentation. Cliff also said, get 3/4 inch wide tape measure.
Oh, yes. That does change the characteristics of the antenna. So, good catch there. So, here is one I built in the past that we're going to do very similar style to it. But literally, it's Harbor Freight tape measure, a T, and then 3 specifically cut lengths of pipe, a random length of pipe that's the handle, and then 2 cross fittings. The most complicated part of this entire project will be this right here. This is the hairpin match that matches our impedance. So that's going to be the complicated part. You got to tune it in a little bit, but it's not too bad. So later, probably in a week or so, you'll be seeing an email come out to the mailing list. So sign up for the mailing list of a short parts list. The only thing that you might have a hard time sourcing is the cable itself. If you don't have the parts to build your own, you can buy one and cut it in half because you only need the one connector. And I'm probably going to direct people towards Show Me Cables, which is down in Chesterfield. You can buy 50 ohm BNC cables fairly inexpensively. Then you don't feel bad about cutting them in half, or buying them off of Amazon. And then you can just buy whatever cable you need to fit your radio. All of my UHF I have adapted to BNC, so my mobile rig, my handheld, and my handheld I'm trying to get a hold of right now. And then if you want the kit we just built, you can either hardwire to the antenna, and on their website they have a 3D printed case that actually fits here in line on the antenna. and holds all the parts and has your BNC cable out. The biggest thing with this kit is you cannot transmit through it. It will blow up this kit and it will probably damage your radio. So this is receive only. So when we build the kit, or when we build the antenna, there's going to be two sets of directions. One is to put the cable hardwired into the offset attenuator, and the other one is to terminate and then do a pair of BNC terminals off of here. So there's the two options. All that will be in the email. And from there, I don't think we've had any more questions pop up in the chat. I want to thank everyone for joining us. Stay tuned for next month, the third Thursday again. We're going to do the antenna build. The following week, or the following month, we haven't determined a specific project yet, because a lot of these the kits have become available and not available depending on the day. So if you have any suggestions of things you would like to see us build, or things that you've built before that you think other people should build, we're still shooting for a hour-long build, so it ends up being an hour-and-a-half long presentation. So anything simple. I know Kyle on his own channel did a build of a power distribution block, which I'm a huge fan of, so that might be something we'll try. But feel free to reach out to me either at ke0fcg@slsrc.org or president@slsrc.org, or sign up for the mailing list and wait for any information coming up, or fill out the info box on the website.
Couple more comments from the YouTube.
Yeah, let's have it.
Cliff was saying that the 1/2-inch wide tape measure is too flexible, so be sure and get that 3/4 as we mentioned earlier. Also, John asked, how close to 4 megahertz was yours showing? His is appearing at 4.000.4. I suppose that's close enough.
Yeah, that's definitely close enough. The crystals, I think they're like a 0.5% tolerance or something like that. I don't remember off the top of my head if it was specified, but that will be well within the bandwidth that your receiver is receiving. So you will be more than fine at anything close to 4.0, because you're not actually going to be tuning your radio during the Fox hunt to 4 megahertz. If we set our Fox for 46 even, you're just going to tune your radio to 50 on the dot. You're not going to tune to, you're going to tune 4 megahertz above or 4 megahertz below the actual frequency of the Fox. So we'll publish all that, and next, when we build the kit with the antenna, we'll hopefully do a live demo of how you actually can follow with the antenna and get close to the actual target with it. Because without the antenna being built yet, we don't have a Fox and we don't have a directional antenna to find it. Any other questions? Oh, that's why my browser froze. That's why I wasn't seeing any comments.
No other comments on YouTube.
All right. Well, thank you very much for joining us. Remember to check our website for any more information. Sign up for a mailing list. If you don't have your license yet and you want to get your license, email education@slsrc.org, and Cliff will send you over study guides for any of the licenses, or all of the licenses if you want to make the jump all the way through. Cliff Clay VE is doing testing this Saturday, and immediately after testing, we have a few new hams that we're expecting to pass. We'll get them on the air, and even if you're at home, you can try reaching out to them and talking. Get their first contacts.
Several thanks for great presentations, guys.
Awesome. All right. I want to thank you, Art, and Larry, and Mark for helping out, and Kyle, who had to run away. I definitely appreciated your help, and I'm sure everyone else is happy they didn't have to just listen to me ramble on for an hour and a half. So until next week, Friday, our meeting, I guess I should have pitched that one before. next week is our monthly meeting, Friday, 7:30. Right? Oh, sorry, 7. The meeting's 7 o'clock next week. This week, as always. Oh man, now I've been talking too long. Next week, Friday, 7 o'clock, our normal general session meeting, and I'm drawing a blank on who a presenter is. It's Ward Silver talking about NFED NFED half waves, I believe. So if you need to find a new antenna for your house, we're going to learn a lot about NFED half waves, and I'm excited about that because I do not have an NFED half wave yet, and should be pretty nice to learn about them. Mark, any closing words? I'm guessing he probably had to run off as well. So thanks a lot for joining us. Definitely remember to check the messages in the chat and the, Ward Silver N0AX will be doing the program. Yes, check the message, check the website for more information, check the comments on the YouTube video for all the links to the various things we mentioned, including the kit. If you haven't built it or haven't bought it yet, through the end of this month, you can still use the discount code SLSRC to get 10% off the kit. And I believe it still works on anything in his store. So he has some straight key kits and some other things. Looks like Mark had his microphone cut out. So he didn't just run away on us. All right. Thank you very much for joining us. And 73.